Hello learners, I am Dr. Prasad Narayan Patil, Assistant Professor in Physics from Ganpat Parsikar College of Education, Harmal, Goa. Here I am discussing in this module wonders of gravitational force. Start. Settlement next. Kuru start. In this module, outline of my talk will be what is gravitational force, universal law of gravity, ocean tides, black holes, free fall and weightlessness. Learning outcomes, learner will able to know gravitational force, law of universal gravitation, origin of ocean tides, existence of black holes, exact meaning of free fall and weightlessness. So let us understand universal law of gravitation. Every object in the universe attracts every other object with a force known as gravitational force. So Newton's law of universal gravitation says that every particle attracts every other particle in the universe with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Mathematically, we can represent force is proportional to uh, two masses, that is capital M and small m, that is equation number 1. And second one, that force is proportional to distance between the two masses, that is 1 by r square. When we combine, we get force is directly proportional to product of two masses and inversely proportional to square of the distance between them. So when we remove the proportionality sign, we are getting one constant. That constant is represented here, gravitational constant. So its value is 6.673 into 10 is to minus 11 Newton meter square per kilogram square. Factor on which gravitation depends. Basically, gravity depends on the distance between the object. So more the distance between the two masses, then less will be the gravitational force. And if distance between the two masses are closer, the more will be the gravitational force. So we all know that gravity is similar like magnet. When the magnets are closer, the attraction is stronger, and when magnets are further apart, the attraction is less. And the factor on which the gravitational not dependent upon the nature, medium, and finally temperature. Importance of the universal law of gravitation. We can get a phenomenon such as the force that binds us to the earth, the motion of moon around the earth, the motion of planets around the sun, the tides due to the moon and the sun. So let us understand ocean tides. So basically tides originate in the ocean and progress towards the coastlines where they are appear as the regular rise and fall of the sea surface. When the highest part of or crest crest of the wave reaches a particular location, high tide occurs. Low tide corresponds to the lowest part of the wave or its trough. So, what causes the ocean tide? They are caused by the gravitational forces exerted on the earth by the moon and lesser extent by the sun. So, we can see in this figure that high tide occurrence on the earth is a reference from the moon, the gravitational force between the moon and the earth, and from the north and south side what we are getting is nothing but the low tide. Another, we can see the ocean tides basically in the sea surface. So when the still water level of the sea surface will be there, so that is like the margin, and we can measure the occurrence of the crest and the trough, and we can decide whether the high tide occurrence is there or the low tide occurrence is there. So basically, in a wave, the wave characteristics is a part of the crest and the trough. So by knowing the crest and the trough, we can determine the occurrence of the high tide or the low tide. Let us understand black hole. A black hole is a region of space-time where gravity is so strong that nothing, including light and other electromagnetic waves, has enough energy to escape it. So basically, a black hole is discovered by John Michell, an English philosopher, in 1783. So the formation of black hole take place basically the death of the massive star. So when the star exhausted the internal thermonuclear fuels in its core after the end of its life of the star, the cores become unstable and gravitationally collapses inward upon itself, and the star outer layer are blown away. Let us see difference between free fall and the weightlessness. Free fall, when a body is falling only under the effect of gravity without external resistance, the fall of the body is called a free fall. A common example of a free fall, what we can consider is the apple falling from the tree, or the stone which is dropping from the hill. So these are the two examples of a free fall. The free fall is the cause of weightlessness. So let us see the weightlessness. When a body is in a state of zero weight, then it is called weightlessness. It is the effect of the free fall. So example of weightlessness on the earth is a astronaut from the rocket in the space can be seen as an example of weightlessness. References for this model will be P.J. Hewitt, Conceptual Physics 12th edition, Pearson, David Halliday, N.R. Rasnig and Walker, Fundamental of Physics Extended 5th edition, John Williamson's, S.C. Verma, Concept of Physics Part 1, Bharati Bhavan. Thank you.
फक्त सर ही एकूच स्लाइड आसा पळय जाला तुमचो रिकॉर्डिंग बरो जाला फक्त ही एक स्लाइड आसा पळय ती परत एकदा म्हणा सो दॅट जर आमकां रिप्लेस करपाक जाय न्ही जाल्यार आमकां घालपाक मेळटलें.
ओके
फक्त तुमचो स्लिप ऑफ टंग जाता वेटलेसनस न्ही
ते म्हाका सारकें जाय
वेटलेसनस जाता सो आनी आवाज खूब कमी जालो एका स्लाइडीक
एका स्लाइडीक
सो ही एकूच स्लाइड तुमी परत म्हणा जर आमकां जर मागीर जाय न्ही जाल्यार आमी ड्रॉप करून घालता
परत करचें पडटलें.
Let us see the difference between free fall and weightlessness. अशें म्हणा. Again, just say this differences.
करू? Okay, let us see the difference between free fall and weightlessness. Free fall, when a body is falling only under the effect of gravity without external resistance, the free fall of body is called a free fall. The example of a free fall here we can see the apple falling from the tree and the stone drop from the hill. So that is the example of a free fall. Weightlessness is a what we can say that when a body is in the state of zero weight, it is called weightlessness. Weightlessness is the effect of a free fall. So common example what we can notice here is the astronaut coming off from the rocket in the space. So this is a common example what we can consider for the weightlessness. And another is the lift which is moving freely on the ground. So that is also the example of a weightlessness on the earth.